This is This Week in Science and Education, episode 28, recorded Tuesday, March 1st, 2011. Unraveling the Mysteries of Parkinson's. It's time for This Week in Science and Education, a show that talks all about all things health, science, research related, and how to take that information and bring it into today's classroom. On today's show, Dr. Almeida from Wilfrid Laurier University unravels the mysteries of Parkinson's disease. All that and more coming up next on This Week in Science and Education. Bandwidth for This Week in Science and Education is provided by Mueller Systems. Need a backup? Check out MuellerDatacom.com/VROC. And by Sheridan Institute of Technology and Advanced Learning. Sheridan students shine brighter. SheridanShineBrighter.com. Hey everybody, it's time for This Week in Science and Education. This is your host, Kevin Cougler, broadcasting today from the VROC office in London, Ontario. Got an interesting show for you today. Dr. Almeida is with us from Wilfrid Laurier University up in Waterloo, Ontario. He's going to talk about Parkinson's disease and unravel some of the mysteries surrounding that disease. I'm very excited to have him here today. Dr. Almeida, thank you for joining us and taking the time to be on the show today.
Happy to be here. Thanks.
So before we get to you and talking about Parkinson's disease, I do want to introduce my co-host, Colin Jagoe. Colin is from the Kawartha Pine Ridge District School Board, as everybody who's been tuning into this show knows very well. He's sitting in his beautiful office in Peterborough, Ontario. How are you, Colin?
I'm great. It's beautiful Peterborough, Ontario. I don't know if I'd call it a beautiful office, however.
Well, we're glad you're with us because, we're a little shy on host today. Our good friend, Dr. Thomas Merritt, has decided he wanted to go brave the cold, chilly weather in Chicago, I guess, eh? So he's not with us today.
Couldn't find any internet connection in Chicago, I guess.
I have a feeling he's doing some really fun stuff, and maybe we were a little bit down on the list of things he wanted to do once he got to Chicago, but that's okay because by golly, we can do this without him. No problem.
We did it without you. I'm sure we can do it without him.
Yeah, well, I'm no great loss. Thomas and you, Colin, you guys are the great losses, and me, no big deal. So. Anyways, I do want to introduce our guest today. Dr. Almeida is the director of the Sun Life Financial Movement Disorders Research and Rehabilitation Center at Wilfrid Laurier University. We're going to learn a little bit about Parkinson's disease and his research. And Dr. Almeida, thank you for joining us. Perhaps you could start the show just by telling us a little bit about yourself and your research.
Sure. Well, as you just said, we're here out in Waterloo, and it's one of the areas that isn't serviced as well in Ontario in terms of support for neurological disorders. So our center is set up halfway between Toronto and London so that we can try and help support people in our communities. We primarily deal with Parkinson's disease, but we do actually deal with all movement disorders, and movement disorders, as you'll find out as we continue to talk about this, is specifically talking about disorders of a very specific part of the brain known as the basal ganglia.
Okay, super. And I understand you have some slides that you might be able to share with us today to kind of help us understand this a little more. If we can,
sure.
I think you're trying to bring those up now.
Put this on, yeah. Can you see that okay?
That looks good, yes.
So what we have here, just as a very simplistic introduction, is a video clip of a patient. And this will kind of give you a sense of what sorts of issues people with Parkinson's might have. Why this might be interesting is that perhaps you might think that this gentleman is walking fairly slowly just because he's old, but in fact, if you notice by his posture and the extreme slowness, in this case, the very small steps that he's taking as he's walking, he does seem to be having quite a bit of difficulty. Now, in order to identify Parkinson's disease, there are some cardinal symptoms. Those cardinal symptoms are listed here on the one side of the screen. One of the most obvious symptoms is something that we call tremor. Now, this isn't the tremor that we have when we drink too much coffee, because, of course, if we drink too much coffee or if we're shivering outside, it's a very, very fast quaking type tremor.
Colin's got his ready to go. Hey, Colin, if you start tremoring during the show, we'll know what Parkinson's. It's just too much coffee. Oh, we've lost Colin. Sorry, Dr. Almeida. Please continue.
Nope, no problem. So, as I was saying, there are some cardinal symptoms that we can identify. The tremor is one of them, and specific to Parkinson's disease, we call it a resting tremor, which means as your hands are sitting at rest, you may start shaking of one of the hands or one of the thumbs, or even what we call a pill rolling behavior, where the one hand or possibly the other starts to shake over time. The other symptoms that we have listed here is rigidity or a stiffness in the joints, bradykinesia, which very simply means slowness of movement, as you saw in this video. And then we have some more severe symptoms, like things such as akinesia or freezing, which perhaps we can take a look at with some videos a little bit later, that shows a very severe deficit, where imagine trying to walk across the street and all of a sudden your feet get completely stuck, and you can't actually take the next step until somebody comes to help you. So very disabilitating, and of course makes it very difficult to maintain your own independence and quality of life.
Mm-hmm. Could be quite dangerous too in a situation like you're describing.
Yes, of course, and one of the goals of our research is to try and understand these symptoms, understand why the brain is causing these sorts of issues to happen in the first place. And then if we can understand the issues, whether it's a shaking in the hand or stiffness of the limbs or this freezing where your feet actually get stuck and you can't walk any further, what is it that we can do if we understand those symptoms and what the real cause of them is? If it's something to do with attention, let's say, because the cars speeding by or the loud music from somebody's roll-down window distracts you, then maybe we have to take those things into consideration to figure out what's causing the patient to freeze in the first place.
Interesting. I have a question, if that's okay. Thinking
Sure.
about the freezing, now, is the freezing sort of on the severe end of the spectrum? And sort of what I'm thinking about is, if someone undergoes this sort of freezing, which is a fairly extreme thing, would they have sort of other sorts of things, like you talked about slow steps and slow movements to begin with and then get to that sort of a point? Or would it be, I'm picturing like somebody like myself sort of moving more or less normally and then freezing, or is it sort of a continuum in there? How does that sort of all play out?
That's kind of interesting. Here in Canada and probably some of the more advanced nations, we're starting to realize that Parkinson's really is probably presents with many different categories, I guess you could call it. So I mentioned the tremor, for example. People who start with tremor, they tend to show tremor and not very many other symptoms other than that tremor. There is a separate type of Parkinson's that we consider this category of posture and gait instability dominant Parkinson's, in which case, and I'm just going to play this video, you can see that this lady has a lot of difficulty even trying to take a step to get out this doorway. So she's trying to leave the clinic room and trying to walk out into the hallway, and you can see that she has to hold on to the walls, and she can barely move her feet. And so that we kind of consider this a separate subcategory of Parkinson's disease, which is obviously very limiting to someone's independence.
Mm-hmm.
Now, is that real-time footage? That's not sped up at all. I mean, she's moving quite quickly, but I imagine that's real-time footage, is it?
Yeah, that is in fact real-time footage. And what you can see here is, in this case, and I'll just play it again as we're talking about this, they have very characteristically these slower and shorter shuffling steps. The shuffling is basically taking her to a halt in this case. The freezing that I mentioned, in both videos that we've looked at so far, you notice what we call a stooped posture, which basically means a cranking forward of the head and a leaning forward of the trunk. And of course some pretty severe postural instability or basically balance issues. As you can see, she has to hold on to her husband to be able to get out the door at all. Mm-hmm. One of the things we've asked ourselves to try and understand this better is, when is walking most affected? Are there things that we might be able to understand based on the environmental situations where this freezing and walking deficits occur? And if you ask our patients, you see things like this, that really they feel that it happens most often in confined and crowded spaces. So imagine the clutter of your kitchen, for example, in a shopping mall when it's Christmas Eve and everyone's running through the mall trying to get their last minute Christmas shopping done. Very interestingly, imagine a doorway or an elevator door where the doors are starting to close. Normally you or I would try and speed up our walking to get into that elevator before the door closes. For some reason in our Parkinson's patients, when they have that angst to try and get through the door, they end up freezing instead of making it through.
Wow.
So there's lots of little examples like that that can start to help us try and understand what's really causing this issue in the first place.
So,
Go ahead, Colin.
yeah, it's like, to me that then says there's some sort of it sounds like it's almost stress related, or if not stress related, the stress brings on some sort of pathway through the brain that then is interrupted by like you said, the basal ganglia areas where the degeneration is occurring. Is that sort of what you're kind of thinking in terms of research, or is there some other way of looking at it?
Yeah, you're exactly right, and in fact, we've started to question these very related issues. Could there be something at the level of the eye where the eyes aren't processing almost like a computer? Maybe the eyes aren't processing things the same way that you or I do. Perhaps there's something related to attention or distraction, that people are more easily distracted and they have to really focus on their walking. It could have something to do with darkness. You know, our patients say the time that they freeze most is waking up in the middle of the night and having to go to the bathroom. Well, imagine the most urgent time that you need to get to the bathroom, and there you are stuck beside your bed and you can't go any further. One of the questions we've asked ourselves about darkness is there perhaps a depth perception problem, that you can't perceive where that light switch is to actually turn that light switch on? And if we could see that light switch, would it make a difference to somebody's ability to be able to walk?
You know, and I'm sitting here thinking that one of the problems associated with movement disorder diseases, and of course Parkinson's in particular, is that there's a certain amount of loss of dignity that comes with a disease of this nature. And I'm not sure about the medications and the treatments that we have developed, and hopefully we'll get into that. But there's really, I'm not sure that there's a medication or a treatment that can really help you with coming to grips with the certain loss of dignity that having a disease such as this, affecting you. How do you find your patients handle just the knowledge of Parkinson's disease, and how do they handle that on a day-to-day basis? That's the human side of it really interests me.
Actually, was there another comment there?
Well, no, I just wanted to sort of add to that, because as I was thinking about it, there's no sort of mental cognitive deficits mostly associated with Parkinson's either, right? So you're fully aware of what's going on, are you not? Yes,
correct. In most cases, until the very end of disease, while there are some cognitive deficits, they're not the primary concern in Parkinson's, for sure. It's definitely, and this is why we categorize everything as movement disorders, because it primarily affects your ability to move first. You're absolutely right, though, that there could be some hints of cognitive deficits in these patients.
So how do people react to that then? Like, just to follow up with Kevin.
Yeah, it really is a challenge. You know, one of the things we're doing on the research front right now, you can imagine the difficulty of telling your own father or mother, I'm sorry to tell you, but you have Parkinson's disease. The very first and obvious question is, well, what does that mean? What am I going to be like in 5 years? Do I have only 5 years? Is it 10 years left to live? So one of the major initiatives that we're in the process of doing right now is trying to document. We've talked about these different subcategories. We've been tracking patients for a very long time now, so that we can be able to report back to them what sorts of changes you should expect over time, and can we do something to help them. Unfortunately for people with Parkinson's disease, there's no actual cure or treatment that will get rid of the symptoms altogether. So what we're left with is trying to figure out how we can mask the symptoms at best. And in some cases, there is the question of whether there's certain things that we can do that might be able to prolong how quickly the brain degenerates. And that kind of brings me to this little slide here. This just to kind of show you, imagine taking your brain if you were to open up your skull, this would be kind of a half slice right down the middle of your brain. And what I'm showing you here in the green is this very central core of the brain, and this is part of the basal ganglia. So you can imagine this central section in Parkinson's disease starts to degenerate over time. And as it degenerates, we lose more and more movement function, and as well cognitive function and other things start to go downhill as well. So really what it is this neurodegenerative process, which is very specifically related to loss of dopamine cells. So dopamine is a chemical that allows the brain to communicate to this specific part of the brain to communicate to other structures. As soon as we start to lose that dopamine, we start to see some of these movement problems. And as you might have guessed, the number one treatment, although it's not a cure, is to replace that dopamine in the form of a pill.
Mm-hmm.
Well, we're looking at that graphic. Some of the people that I know that are afflicted with Parkinson's, a couple of them find it quite difficult to be in crowded rooms and to have a lot of ambient noise going on around them and focusing through that. Is there a certain part of the brain that is affected? Maybe you could point it out to us on your graphic there.
Well, that's actually a very interesting question, because if you think about it, this part up here, this is the part that most people would expect to see in a cartoon. This would be called the frontal lobe, and the frontal lobe is supposed to be the part that helps plan everything that we do on a daily basis. So you can imagine that as this part of the brain wants to send its messages out to our arms or our legs or our mouth to speak, it has to send that message down towards this basal ganglia, through the brainstem, down through our spinal cord, and eventually out to our hands and legs or mouth, whatever's trying to move. So as the copy of the message goes through this structure, this is where we have the problem. So you could potentially imagine this almost like a filter, where you've got some of the message going directly through, but then the part of the message that goes through the filter isn't really getting through all that well because of this lack of dopamine. And you end up having a mismatch of information that causes some of these difficulties.
Okay. And, Parkinson's has been around for a long time, obviously. But I get the feeling that in the last 15 to 20 years, we've made some pretty good strides in developing cures, or not cures, sorry, but treatments and, ways of coping with the disease. Maybe talk a little bit about what some of those treatments might be for people.
Sure. So, the very first treatment is, of course, replacing that dopamine. So if we need this chemical dopamine to allow this green part of the brain to be able to communicate with the rest of the brain, then very simply we could take pills that are almost the compound dopamine. So we can synthetically make it, and we make it in the form of something called levodopa. We make it in that form because when our stomach gets it and we try and bring it up to the brain, dopamine itself wouldn't actually cross what we have as a very selective and protective filter called the blood-brain barrier. So we have to make it in the form of levodopa so that it can actually cross the blood-brain barrier, enter the brain, and then, of course, you have the dopamine available to the brain to be able to use. What I didn't tell you is that if you noticed in that second patient, and maybe I can skip back to it quickly, you notice a lot of extra movements, that her head is kind of moving and her arms are kind of moving and her knees seem to also be kind of moving. This, by most people, is considered a side effect of having taken that dopamine medication for too long. So it's kind of a catch-22. So you've got the problem of the feet, that's the normal symptom of Parkinson's that requires the dopamine. But if you take too much of the dopamine, as you can see here, you end up with all these extra movements because it's making the rest of the body move more than it's supposed to. So there's certainly limitations to medications alone, and this is one of the things that we've been trying to work on, is finding other answers as to what you might be able to do to help the brain.
Is there any type of, sorry, I see you have another slide here, and we'll get to that obviously, but I was just wondering, is there any type of physiotherapy treatment that patients undergo as part of their treatment plan?
That's actually a perfect segue, because if we were to look at animal models, and because we know that there are certain chemical substances that can cause damage to the brain, we could actually give these chemicals and induce Parkinson's in animal models. So in rats or monkeys or dogs, we could give them Parkinson's disease on purpose for a research purpose. I don't do this sort of research myself. But imagine giving an animal Parkinson's so that we can study new treatments and trying to figure out if they can actually recover from their symptoms. And can the brain actually regenerate as well? What some studies have shown is that if you give a rat Parkinson's disease, but then you force it to do exercise on a wheel, if you force it to do that exercise 7 days a week, you can in fact get some replenishing of that dopamine that was lost. So there's promise, of course, that on the animal side, if animals can reproduce dopamine in those cells, then maybe there's a way that we could try and have humans do exercise as well. So one of our other main goals of research at our center is to try and develop rehab programs and compare different types of exercise rehab programs to see if there's something that is scientifically to actually help improve the symptoms of Parkinson's disease.
Just a few years ago, we had a what we call a Reaching Every Student session. So part of what we do with students in the classroom, and we did a session on Parkinson's disease, and it was wonderful for the students to hear, firsthand from one of our researcher heroes, as we like to call them. You guys are on the front lines doing this type of research, which the general public really needs to appreciate. But this one little girl, not little girl, but it's grade 9 student, she thanked the researcher very much for coming and giving the talk to the class through video, and she said, because of you, and you didn't know this, but my mother is your patient, and before she came to see you, she didn't have a quality of life. And after she saw you and through your work, I'm able to take walks with my mom now, and I realize it might be just for a few more years, but those are incredibly valuable years. And it was one of those moments, Dr. Almeida, where you just say, wow, this is the value, of this type of reaching out to the public at large and to the education system. And it really speaks to the the fantastic research that does take place in institutions and labs such as yours. So we thank you for that. Colin, any questions for Dr. Almeida? I know you keep leaving us and coming back in. You're probably having your coffee camera.
No, I'm not having my coffee. I apologize for popping back in. I just, it says the far side is disconnecting me, so I'm going to blame Kevin on that one. I don't know what's happening today.
You had a comment.
I know. I've actually got two things, and one of them, we found a news item that we can talk about later that has to do with treatment, and it has to do with the dopamine connection. But one of the things we haven't touched on is something that I honestly don't know a lot about, but it's the whole idea of treating Parkinson's with stem cell replacement of some description, right? Because there was a lot of news a few years ago in the States around the whole stem cell research, controversy, and the government putting holds on various lines and all this sort of thing. And there were some celebrities backing it, particularly somebody like Michael J. Fox who has Parkinson's. Maybe just give us an idea of how something like a stem cell research could then help with treatment of Parkinson's, and what they hope to do with that sort of approach.
Sure, and for that I'll pull back this slide again. So that's obviously a really promising area of research, although it hasn't been all that fruitful right now. I think down the road it may actually have a whole lot of potential. So you can imagine, again, if we were pointing out this part of the brain that has deteriorated over time, the theory behind it is that if we took very, very early cells that haven't actually specialized yet from fetal tissue or some sort of tissue that needs to get the signal to specialize into something, if we could embed that into this part of the brain, then perhaps the signals from this part of the brain that's deteriorating would actually tell that neural tissue to start to, fetal tissue to start to develop into brain tissue.
Right.
And if it did, it should hopefully specialize into basal ganglia tissue specifically and produce more dopamine. The challenge, of course, as we kind of talked a little bit about already, the brain and our human bodies in general are very, very sensitive to introducing things that are essentially considered foreign, which is a really smart defense mechanism of our human bodies. So anytime we introduce something foreign, whether it's the most obvious, most common source, I guess, right now is fetal pig tissue.
Okay.
The body's very smart at realizing that fetal pig tissue is not the same as human tissue. And then, of course, there comes the debate about what about using human fetal tissue, and then where do we get that human fetal tissue from? So there's certainly an ethical debate about whether it's right to borrow that tissue from those types of sources as well.
Sure.
Up until now, there has not been a tremendous amount of success. We do have patients that happen to be involved in our center where they've been involved in these clinical trials. And imagine basically drilling a hole through the top of the head. They send down a metal rod and right down to the level of the basal ganglia, and then they could essentially implant this tissue.
Wow.
If we really want to do this as an experiment, science would tell us that in half of the patients we should put the fetal tissue in, and in other patients we should just drill the hole, send the metal probe down, but not actually leave anything there, and withdraw the probe. And then, of course, over time we should track these patients and see if anyone gets better, and if they do, hopefully it's the people that have the implant and not the other people. So far, it's been pretty difficult to tell the difference between those two groups, which is a hint that whether or not you're doing something, implanting any tissue, it doesn't seem to be taking.
Right. Interesting.
Sometimes that's half the battle, though. I mean, you have to try these things in order to find out what doesn't work so you can move on to something else. So,
absolutely.
Yes, of course, and that's a part of the issue.
Sure. We're talking today with Dr. Almeida from Wilfrid Laurier University about Parkinson's disease, and coming up, we're going to be talking about a news item that's related to Parkinson's disease that Colin's going to share with us. But before we get to that, I do want to take a quick 2-minute break here to talk about our good friends over at Mueller Systems in Woodstock, Ontario. They are the company that helps us back up all of our important documents and files and pictures. And Dr. Almeida, I'm sure you have need of backing up your system at the university. You don't want to lose all those precious hours and hours of work that's gone into collecting all of your data. And this is what Mueller Systems do as well. So if you're out there and you need some backup help, you need a backup in the cloud, we encourage you to visit MuellerData.com/VROC. That's MuellerData.com/VROC. If you visit that website today, you'll be able to download their software and install it and try it free for 90 days. We encourage you to do so, and we thank Mueller Systems for their support. Back with the show, Colin. Do you want to? You were talking before we came on the show about a news item you'd like to bring to the table that's directly related to this.
Sure, it's interesting. As we were preparing for the show, we got sent some news releases about various Parkinson's-related stories, and I went on to the website where we got some of those from today. Actually, it's ScienceDaily.com, and they have a whole section on health and whatnot, and one section dealing specifically with Parkinson's. But a story was posted yesterday that is really kind of interesting. I don't know if you had seen any of this or know of this research that was posted, Doctor, but it's totally in line with some of the things you were talking about today around the dopamine replacement, or not dopamine replacement, but production of dopamine, I guess. And I'll just sort of highlight out of the article. It's Professor Kanthasamy, I'm not sure if I'm pronouncing that right, who has produced some research talking about, that it's that lack of dopamine that causes some of the problems with Parkinson's. And in some previous research, he'd found a protein that was responsible for killing some of the dopamine-producing cells. Right, so he had come up with that bit of research, and now in this new research, he's shown how to modify the production of this protein and inhibit the production of the protein that then led to the killing of the dopamine cells. Right, so it's not replacing dopamine, but it's sort of inhibiting that which is causing the killing of the dopamine-producing cells, which then, of course, means that you're going to not lose those cells as fast and result in higher dopamine levels, and then hopefully, a lower rate of degeneration or whatever. maybe just, and that's sort of it, and they go through and talk about some of the specifics of it, but just maybe if you can sort of comment on that as something that, I mean, and you always hear these sort of news releases, like the headline, which is, new hope for solving Parkinson's puzzle, and I mean, you always get these sort of headlines on general science reporting, but maybe speak to something like that in the research that's going on right now.
Sure. Yeah, in many ways, this is kind of a similar approach to what we're trying to do. Instead of dealing with what you see right in front of you, it sounds like what this researcher is doing is trying to think about what could have caused the issue in the first place, so that if we can correct the cause, then we no longer have the problem with the brain. Very similarly with us, we're trying to understand what causes the movement impairments, so that if we can change, let's say, the attention or the distraction or the visual stimuli that the person is looking at, then perhaps we can get rid of the movement problems in the first place. So it's a very smart approach to try and think one step before and think of what's really causing the issue in the first place. So I am a little bit familiar with some of this research that's argued that there are proteins that essentially act like a poison, in the sense that they tell the brain to self-destruct, tell those specific neurons of the basal ganglia that they're no longer needed and they should start degenerating. So does it make sense to do that? Yes, of course, it makes a lot of sense. We could go one step even further back in the chain, and we could think about DNA. DNA tells our body what to do and how to develop and everything else. And so, of course, many people will ask, is there a genetic component to Parkinson's? Because if we could identify those genes that produce the proteins in the first place, maybe we could change those genes through gene therapy. And once we have that gene therapy in place and it's effective, then theoretically we should be able to avoid the proteins from being produced and therefore never see Parkinson's again.
Okay.
So there's lots of brilliant people out there that try and take steps back and look at what could be initially causing the problem in the first place.
Right. So that thing brings me to another question. And what is the genetic factor? Some of the reading I was doing seemed to suggest that it was pretty low in terms of an actual root cause. What's your idea on that?
Yeah. To be honest, this is where research there's kind of a debate there, really.
Okay.
I would say that there is a range between studies that are showing as little as 15% of all Parkinson's has a genetic basis.
Which was the number I read
studies,
online, yeah.
Yeah, have shown up to 40% of Parkinson's being related to genetics. I can tell you that there are quite a few genes now, well over 10 at least, genes that have been identified that do specifically relate to Parkinson's disease. One perhaps interesting story, though, is that in some cases, when we look for genetics, obviously the critical thing to look for is if families or siblings end up having the same disorder. And I recall the story of a family in Italy where all the sons seemed to have Parkinson's disease and the daughters didn't. So, of course, it looks like it's something that's an X-linked trait.
Right.
However, what they discovered afterwards is that all the boys also worked on the farmland of that property, whereas the girls didn't really do much of the farming. Therefore, they realized that there was something in the insecticides and the soil that could have been an environmental toxin that was actually causing the symptoms. So because all the boys had some symptoms of Parkinson's, we assumed it was genetic, but we were actually wrong because really there was some environmental influence as well.
Okay.
Yeah, that's a great point. You talked about brilliant minds, too, and I'm thinking there's an awful lot of brilliant minds out there that might be listening to this show after the fact here, we hope, in the public education system. We don't have a lot of time left, but I would like you to help me inspire some of our young new scientists, and challenge them to go into this particular field of research. Maybe talk a little bit about how rewarding your career has been and how you got to be where you are today.
Yeah, for sure. Our university has lots of partnerships with high school students. We're even involved in some projects with grade school students. I'm a science fair judge myself for Waterloo-Wellington region. And it really is great to see these young minds at work, because sometimes they come up with some pretty interesting things. For myself, I would have asked a very simplistic question in an undergraduate university class, and it's led me to what I'm doing right now. Now we deal with over 800 patients with Parkinson's disease and other movement disorders. And the reward is actually dealing with the patients themselves. Imagine somebody who comes in, and I'm sure you hear these sorts of stories all the time, but to experience it firsthand when somebody comes in a wheelchair, can barely talk, and you say, give me 3 months, and in 3 months you'll be at least out of that wheelchair and able to communicate with your husband again. That sort of reward for me, all the research and all the things that we do, at the end of the day, is focused on helping these patients. And I think that's why the patients are so eager to come back. Our students, most of our research is student-driven. So they're people that come from high school to Laurier, and from Laurier they have a chance to hands-on interact with these patients and see what they can do to help. You'd be amazed how much you can learn just from seeing somebody with these disorders, working with them one-on-one to try and figure out what you can actually do to help them. Lots of ideas come out, and with those ideas we end up with the research that we're doing right now.
And if you had to point them to a website or a particular way to find out more about you, your information, your research, where would you ask them to visit, Dr. Almeida?
Oh, yes. So, of course, you could go to Wilfrid Laurier University's website, which is www.wlu.ca. And very simply, if you typed in the search word movement disorders or Parkinson's, I'm pretty sure you'd be able to find us.
That sounds great. Colin, if we have time for maybe one last quick question, and then we've got to wrap it up, if you're interested in taking me up on it.
Always. You know what? I keep coming back to, and I know there's no answer to this question, which I guess maybe is a good question to leave on. Identifying causes, right? We talked about the genetic component. You talked about, maybe this pesticide-related thing. So is there environmental indicators? Is there sheer dumb luck indicators?
Yeah, it is a tough question. To talk about the newspaper, I assumed you were about to talk about the story that just came out in the Toronto Star. There was something that some of the patients brought to my attention, explaining that Agent Orange was used under all the hydro lines across Ontario, and it was a 30-meter span, the length of 4/5 around the entire world. That's pretty worrisome, considering that was the #1 chemical agent used in warfare in Vietnam. And we had young high school kids strapping metal backpacks on their backs, spraying this stuff freely to try and kill all the weeds and grass and trees underneath those hydro lines. So, certainly there does need to be that sort of research done, and we're fortunate enough to have a big population base that, in fact, as patients come in, one of the very first things I ask them is, where did you live over the 10-year period where you started to notice your symptoms? And very simply, we're trying to track that on a map, if you can believe it, very just easily with push pins, just to try and see if there's clusters around rivers, around hospitals, around factories, different types of things. Are you very close to the airport? Those sorts of things, so that we can start to see if there's clusters and things that we should be aware of in our environment that we might want to be concerned about in the future as we develop more land.
Well, this has been a fascinating discussion today, and I have a feeling we've just scratched the surface on different questions that we could be posing to you. I do want to thank you very much for coming on the show today. I know I speak for Colin as well, and I won't ask him to thank you personally because he might drop again. You never know. But
I'll say thank you anyway. Thanks very much for your time.
You're welcome. Anytime.
So, on behalf of Colin Jagoe from the Kawartha Pioneers District School Board and Dr. Almeida from Wilfrid Laurier University, this is Kevin Cougler, a virtual researcher oncologist, reminding everybody to check out all of our episodes at T-WiSE.vrock.ca, and we thank you very much for tuning in. We look forward to seeing you again next week. Have a good week, everyone.